Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of vectors as velocity. So as per the problem, Dave wants to cross a 200-meter wide river whose current flows at 5.5 meters per second. The marina he wants to visit is located at an angle of south 45 degrees west from his starting position. Dave can paddle his canoe at 4 meters per second in still water. In part A, we have to find the direction in which he should head to get to the marina. So the first step is to draw a diagram for this problem to understand what's given and what we need to find. So let's start with the river. So let's assume this is the river and it's flowing from top to bottom. And the river speed is 5.5 meters per second. Now, as per the problem, the marina that Dave wants to visit is located at an angle of south 45 degrees west from his starting position. So let's assume his starting position is this point D, and the marina is at point M on the other side of the river. So he has to start pedaling in a direction so that he gets to the marina. So the resultant velocity of Dave should be in the direction of the marina. As per the problem, the marina is at an angle of south 45 degrees west. So we can draw the main directions. From south, we have to go 45 degrees towards the west. This angle here is equal to 45 degrees. Let's assume Dave has to pedal in the upstream direction at an angle theta with the bank of the river. So this is the vector for Dave's pedaling his canoe in still water. And its magnitude is 4 meters per second. Now we can draw a vector triangle in which we should arrange the vector for Dave's velocity in still water and the velocity of the current in tip to tail or head to tail arrangement so that we can make our vector triangle. So let's start with the Dave's velocity in still water. The water in the river is moving in the downward direction, and the resultant velocity for Dave can be this third side in this triangle. So this is the vector triangle we have to analyze. Now in this triangle, this bottom corner angle is 45 degrees because of this Z pattern. Similarly, the top angle in the triangle is equal to theta. because of the Z pattern. Now the next step is to find this angle X, or the third angle in this vector triangle. And for that, we'll have to use the sine law equation. So our sine law equation will be sine x over, so the magnitude of the vector that's opposite to angle x is 5.5, and sine, and the length of the side opposite to angle 45 degrees is equal to the magnitude of Dave's paddling in still water. Now we can solve for x, so we can cross multiply 5.5. Now we can evaluate this term. So I got, now we can do the inverse of sine. So I got almost 76.5 degrees. Now we can calculate the value of angle theta. So angles theta, x and 45 degrees lie along a straight line. So their sum is equal to 180 degrees. So we can use this equation to find the value of angle theta. So I got 58.5 degrees. So the direction can be described as the angle is 58.5 degrees with the river bank in the upstream direction. So this should be the final answer for part A. Now we can analyze part B. In part B, we have to find how long will the trip take. Now, Dave has to travel across the river, and that's a distance of 200 meters. So we have to find the time it will take to travel these 200 meters across the river. And next, we have to find the component of his paddle speed across the river. So for that, we have to analyze the vector for his paddle speed and find the component of that paddle speed that is across the river. So we should draw a vector triangle for his paddle speed. So we have to find the x component for his paddle speed. And in this triangle, the bottom angle is 58.5 degrees. So we can use SOHCAHTOA to find the value of x because this is a right angle triangle. So the x and y components are perpendicular to each other. So for x component, we can use the sine ratio. The formula for sine is opposite over hypotenuse. We can cross multiply the 4. Now we can evaluate it. So I got 3.41. The unit is meters per second. So this is Dave's speed across the river. So we have to find the time. So we should use the formula for time. Time is equal to distance over speed. And the distance is 200 meters. And the speed is 3.41. So I got T equals 58.65 and the unit is seconds. So this should be the final answer for part B. So this is the time it will take Dave to get to the marina. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.